Good day, I'm Ramos. Together with my partner Bobis, we'll be presenting in this video our thesis paper entitled Smart Irrigation System based on Evapotranspiration using Penman-Monteith and Hargreaves-Samani for macroclimate data. Irrigation is the process of allowing water to pass through different channels in order to supply crops or vegetation with water that is essential to their growth. Use in technology in irrigation is not entirely new. As a matter of fact, it is an emerging field where there could be numerous potential and findings that could result in the production of crops. Smart irrigation systems are a complex combination of different sensors that follows different protocols depending on the crop's needs. The general purpose of this study is to develop a smart irrigation system based on evapotranspiration, while the specific objectives of the research would be to develop an AD-based irrigation system that implements Hargreaves and Penman-Monteith equation, to develop a mechanism to acquire macro weather data that will be used in evapotranspiration computation of water loss, and to implement the proposed irrigation system and compare with the conventional irrigation and the cultivation of Brassicas subchinensis or bok choy. The purpose of our study is to develop an irrigation system that is capable of adjusting to the needs of bok choy plant by fetching climate parameters from an API and through evapotranspiration controllers. This would prove to be significant as a prototype could reduce water consumption, for it will adapt automatically to what the bok choy plant would need on its own. For the scope and limitation, the researchers are also to observe the results of the experiments on a smaller scale to see the effectiveness of the developed prototype. It will simply rely on the data that is being fed onto the prototype using a weather API. The prototype would fail to function if key resources such as internet connectivity is unavailable. This goes for the physical resources such as water that will be used for irrigation. The conceptual framework simplified the whole system in standard input, process, and output. The variables needed to compute for evapotranspiration using two equations have been laid out in the input box. The process listed down in the process box is the computation of evapotranspiration value using the two equations. The expected output will be the amount of water that is lost due to evapotranspiration and rain gauge reading, and the calculated amount of water to be dispensed. Figure 3 shows the hardware design of the system. Raspberry Pi is the microcontroller used in the system. It is used to get the data from the API weather station, wherein the data gathered will be used to compute for the value of evapotranspiration. The LCD modules were advised are to be displayed, such as the amount of water to be irrigated. The solenoid valve is utilized to control the progression of water. Meanwhile, the water flow sensor quantifies the measures of water streaming. If it rains, the rainfall water is collected and measured by utilizing the rain gauge, and the total amount collected will be subtracted to the amount of water required by the bok choy plant per day. If the amount of rainfall water collected is greater or equal to the amount of water required, the irrigation of the day will be postponed. This is the equation for the Hargreaves-Samani and Penman-Monteith equation. As for the system flowchart, once it is turned on, the system will get the data from the API weather station, which contains meteorological data, and get the rain gauge reading. It will be read and stored by the system. The variables, pins, and constant assignments are also included. Next, the system will check if the time is already 9 o'clock in the morning. The irrigation process will be performed daily, which makes the 9 o'clock in the morning the marker for us to irrigate daily.
As for demonstration, here is our prototype. As you can see, it is already the irrigation value is 542.8. As you can see, we can also check here in our terminal. You can also see here the bok choy growth from week 1 to week 3, also from week 4 to week 6. Results, table 1 shows the weekly average amount of water dispensed with a conventional system and smart irrigation device. It is shown here that the total amount of water dispensed by the smart irrigation system is lesser compared to the amount of water dispensed using conventional method. Table 2, bok choy leaf height comparison for the conventional and smart irrigation using Hargreaves-Samani. Table 3 shows the weekly recorded tallest leaf height of the every bok choy plant observed when comparing the conventional method and smart irrigation system using Penman-Monteith equation. Figure 6 and 7 shows the graph of the conventional method and the developed device using Hargreaves-Samani and Penman-Monteith equation. The blue line shows the increase in leaf height of the conventional method, while the orange line illustrates the increase in leaf height of the developed system using Penman-Monteith equation and Hargreaves-Samani equation. Statistical analysis of plant height. The null hypothesis states that there is no significant difference in terms of plant leaves height using conventional method and using developed smart irrigation system. The alternative hypothesis expresses that there is a significant difference in terms of plant height using conventional method and using developed smart irrigation system. Statistical results. Table 4 illustrates the two sample t-tests for the leaves height or length. Setup 1 refers to the comparison of data between conventional and developed system using Hargreaves-Samani equation, while setup 2 refers to the Penman-Monteith equation. Based on the data presented, T statistics value is less than T critical value for both setups, which shows the null hypothesis, which states that there is no significant difference in terms of plant leaves height using conventional method and using developed smart irrigation should not be rejected. Conclusion. The researchers successfully created a smart irrigation system based for bok choy or pet choy. We can also observe that the system can detect rainfall and reduce the amount of water to be irrigated depending on the amount of rainfall data. The test shows 5,936.9 ml of water was saved by the ET-based smart irrigation device using Hargreaves-Samani equation, while 9,229.16 ml of water was saved using the Penman-Monteith equation smart irrigation system. Recommendation. Future studies could consider the use of solar energy as a power source to the system to make use of renewable energy and lower maintenance costs for the system. Monitoring of sensor can also be added through the use of Internet of Things. A mobile application can also be made so that users of the device can easily automate the system and view updates even when they are at a different place. Future researchers can also implement the system in a bigger scale, such as farms. So that's all for our group. Thank you.